In this video, we will learn about measurements of physical quantities and units. Now, physical quantities are defined as the units in terms of which laws of physics can be expressed and which can be measured directly or by some indirect methods like length, distance, area, volume, velocity, acceleration, mass, time, density, force, work, energy, and power. Now, these are some examples of commonly used physical quantities. Now, measurements of a physical quantity tells us how big or small the given quantity is. Measurement of a physical quantity is essentially a process of comparing the given physical quantity with the chosen standard quantity of the same nature. The chosen standard is also known as the unit of that physical quantity. Now, thus a unit is a suitable standard in terms of which we may measure the magnitudes of quantities of the same nature. Now, the result of measurement of a physical quantity is expressed in the term of the following two. First is the unit in term of which the given physical quantity is being measured. Second is the numerical value of the physical quantity, which tells us how many times the selected unit is contained in a given quantity. Thus, the measure Q of a physical quantity is expressed as the product of numerical value n and size of the unit U. Mathematically, measure of a physical quantity is numerical value into size of the unit. Now, for example, when you say that the mass of a given bag of sugar is 5 kg, here 5 and kg is the unit and 5 is the mass is measured in terms of the unit kilogram and the numerical value of the mass is 5 times the mass of standard kilogram. Okay. Again, we say that length of a sari is 6 meter. Here meter is the unit of length and 6 is the numerical value of the length of that sari. For the above relation Q equals NU, it is also clear that for a given quantity, the numerical value N is more if size U of a selected unit is small and vice versa. For example, a length of 2 meter may also be expressed as 200 centimeter and the mass 3 kg can also be read to as 3000 gram. Now in general, if a given physical quantity Q is measured in two unit system U1 and U2 as the respective size of the unit and N1 and N2 as the numerical value of the given quantity Q, then we can say N1 U1 equals N2 U2. For example, if a given physical quantity is 3 kg, it can also be written to as 3000 gram. So 3 equals 3000 when U1 is kg and U2 is gram. Okay. This is what is meant by this particular statement and this particular relation. Now, choice of a standard unit. A unit chosen for measuring a physical quantity should satisfy the following quantities. First is it should be well defined without any ambiguity. Second is it should be of an appropriate size. The unit should neither be too large nor to be too small in comparison to the quantities of similar nature to be measured. Third is it should be easily accessible and should be easily reproducible. Fourth is the unit value should not change with time or from place to place, right? The unit should not change with the variation in physical conditions such as temperature, pressure, atmospheric humidity, etc. And the unit should be widely accepted by the society. I hope this topic is clear to you. Thank you.